Hello and welcome to the Quantitative Graphing and Motion Mapping video tutorial. Here we have a ball at the top of a ramp that will move down the ramp and to the left. The ball is starting at a position of 20 meters, so we're going to see our position graph start here, and then it's going to reach a position of 10 meters over the course of 6 seconds. So we're going to see our first part of the graph end at this location here. The ball is going to cover less position with time at first, and as the ball speeds up, it will cover more and more position with time, and that looks like this. So you can notice not very much position is covered in the first second, but as you get on to say the fourth second, a lot of position is covered during the fourth second, all the way from here to here, compared to here. Once the ball reaches the 10-meter mark, the ball is no longer going to speed up. It will move at a nice steady rate from 10 to 0. So we're going to see position change at a nice steady rate from 10 to 0 over the course of 3 seconds. So that's going to look like a nice steady line here. To draw the motion map for this, we're going to start at 20 meters, and we're going to see the ball speed up from 20 to 10 meters. This is going to occur for 6 seconds, so we're going to draw 6 arrows, getting progressively larger because each arrow is covering more and more position with time. For the last 3 seconds, which would be 3 arrows, we're going to see no change in velocity, so we're going to cover the same amount of position each second that goes by. These arrows should all be the same length as this final arrow from the first set, because once we reach 10 meters, the velocity is not changing anymore. To draw a velocity graph, we're going to notice that the ball starts with 0 velocity, so that's going to be right here on our graph, and then the ball is going to travel in the negative direction, getting faster and faster in the negative direction. That's going to be negative velocity. So we're going to see the ball start 0, and then over the course of 6 seconds reach a pretty good negative velocity at a nice steady rate. Once the ball reaches the 10-meter mark, or the first 6 seconds of the trip, the ball is now no longer going to change its velocity. So whatever you ended with is going to continue for another 3 seconds. To draw this on the motion map, we're going to start at 0 meters per second, and we're going to notice that the velocity is going to become more and more negative with time at a nice steady decrease in velocity for 6 seconds. So there should be 6 arrows to represent that. Then the velocity is no longer going to change at the 6-second mark. So whatever velocity you end with, that's going to be our velocity for the next 3 seconds. To show that, we're going to show dots. We can't draw arrows because an arrow would imply change, and there is no change in velocity for the final 3 seconds. For the acceleration graph, we know that the ball is accelerating negatively for the first 10 meters. The reason why we know this is because the initial velocity of the ball is 0, and then we saw earlier it became, say, -1 meters per second, -2, -3. That means that that's a change of -1 meters per second every second. So that's a negative acceleration. So we're going to see a negative acceleration. The actual value somewhere around 0.5 negative. After the first 6 seconds, the ball is not going to speed up anymore. It's also not slowing down. It is not changing velocity, so that means 0 acceleration for the final 3 seconds of the trip from 6 to 9. To draw this on the motion map, we're going to show that the acceleration was a nice steady about -0.5 meters per second squared for the first 6 seconds. We show this with the dots, 6 of them to represent the 6 seconds, and then there was no acceleration for the final 3 seconds. The number for none is 0, so we're going to show 3 dots to represent the 3 seconds of time that the ball was not accelerating. Thank you for watching the Quantitative Graphing and Motion Mapping video tutorial.